Okay, in this vodcast, what we're going to do is go over the different forms of matter, and we call this the classification of matter. Since chemistry is defined as the study of matter and the changes that it undergoes, it's appropriate to go over what different classifications of matter we have. So let's get started here. Let me get myself a pen again. Okay, what we're going to do is break down matter into different classifications. And as you can see, when you take a look at matter, what you want to do is, first of all, is decide, is it a variable composition or not? When we say variable composition, what that means is, do the different parts in the substance that you're talking about, can they be in different proportions? In other words, if you were to take, say, sand and water and put them together in a mixture, you could add more sand or less sand, more water or less water, so your composition can vary depending on how much of each compound you put in the mixture. On the other hand, if the composition is not variable, in other words, let's say you just have the compound water. There's 2 hydrogens for every 1 oxygen. If you vary that composition, so for example, put 2 hydrogens for every 2 oxygens, you have 2 completely different compounds. So if the composition is not variable, that means we would have a pure substance. If the composition is variable, that means we have a mixture. Alright, let's talk about pure substances first. Pure substances are going to fall into 2 categories. A pure substance is either an element or it's a compound. And what we can say is compounds are more than 1 atom bonded together. For example, water. Elements are the individual atoms. Now we'll talk about the difference between atoms and elements in a bit, but for right now we can say an element is the individual atom. In other words, the element hydrogen, the element oxygen make up the compound water, which is 2 hydrogens and an oxygen bonded together. Now, the difference between elements and atoms. When we say element, that's the general term. For example, carbon. Carbon has 3 different isotopes, and we'll talk about what isotopes mean a little bit later, but when we talk about the 3 different isotopes, we're talking about the general element carbon. The individual atoms of carbon are, say, the carbon-12 atom, or the carbon-13 atom, etc. For right now, what you want to do is think about elements as the things that appear on the periodic table, and atoms are simply an individual piece of the element. So an individual carbon atom making up the carbon element. Alright, if our composition is variable, then what we have is a mixture. And as we talked about earlier, that could be a mixture of 2 different pure substances. For example, sand and water, or salt and water. In other words, you're just taking more than 1 compound, or more than 1 element for that matter, and putting them together to form a mixture of 2 substances. Mixtures can be either heterogeneous or homogeneous. Hetero, the prefix hetero meaning different, the prefix homo meaning same. So when we have a heterogeneous mixture, it means we can see distinguishable parts. In other words, think of sand and water put together. You could see the different particles of sand in the water, so you would have a heterogeneous mixture. On the other hand, if you had salt water, in other words, you took salt and put it in water, and it dissolved, you wouldn't be able to see distinguishable parts, so you would have a homogeneous mixture. Alright, so let's just go through these again, and then we'll review. So we said matter can be broken up into 2 categories, pure substances or mixtures. Pure substances are either elements or compounds. Elements are the individual atoms. Compounds are when you take more than 1 atom, put them together to form a compound. And it's important to note out that these atoms will be bonded together. In other words, they're chemically bonded together. Mixtures, on the other hand, have a variable composition. So you are taking two compounds or two elements and you are simply putting them together in the same region. In other words, taking salt and putting it in water to make salt water. Now you're not chemically reacting these together, you're just putting them together in the same container. When we have mixtures, we said that they can be broken up into two types. Homogeneous mixtures mean you can't see distinguishable parts. In fact, an example of that would be salt water. So we put in salt in water. A heterogeneous mixture is when you can see distinguishable parts. Remember, different parts, same, or we should, yeah. Okay, so an example of a heterogeneous mixture would be, say, sand in water. The sand won't dissolve, so you could see the individual sand particles as opposed to not being able to see individual salt particles. All right. We said that pure substances then were elements, say the element carbon. Atoms of the element are the individual pieces that make up that element. So in other words, maybe an atom of carbon-12 or an atom of carbon-13. And again, we'll talk later about what those designations mean. The other type of pure substance we have is a compound. In other words, take more than one atom, chemically bond them together, and you have what we call a compound. So just to review, matter is anything that takes up space and has mass. In fact, I don't think we defined that in the beginning. So let's define matter as anything that has volume and mass. It's broken into two categories: mixtures, substances. Mixtures are either heterogeneous or homogeneous. Pure substances are either elements or compounds. Now, most of this stuff should be a review from an earlier physical science course that you had. That's why we went through it kind of fast. As we move on through the year, it's very important to distinguish between mixtures and what we call pure substances, or in other words, elements and compounds. And as we talk about reactions and solubility and other processes, you always want to keep those two items separated.